just some review items here. Find the measure of each angle in the polygon. So being that number 1 is a quadrilateral, okay, that means it's going to add up to 360. So I just need to add all 4 up to 360. I'm going to do some of this in my head. 2x plus 2x is 4x. 80, I'm just going to combine these in my head. 80 minus 20 is 60. 60 plus 48 is 108. Plus 12 is 120. That equals 360 degrees. If I subtract 120, 4x equals 240. And if I divide by 4, I get x equals 60. That will be the answer. Now, number 2 is pretty much going to be the same problem. I'm not going to do it, but basically we just add all 3 angles up and set it equal to 180 because it's a triangle. Okay. Now, number 3, I could set this equal to 360, knowing that this angle and this angle are the same, and this angle and this angle are the same. That doesn't really show up right. That's what I'm going for. But we also know that consecutive angles are supplementary. So these two add up to 180. So I can just write that. I'm going to do something in my head. So 2x plus 4x is 6x. 7 minus 1 is 6. That's going to equal 180. I'm going to subtract 6. So that's going to be 174. And then I just take 174 divided by 6, which is 29.
Find one song, a song.
And in case you want to do number 2 for practice, I will tell you that the answer is x equals 33. Okay, find the area of the geometric figure. So we need, for number 1, we need the length and width, the size, whatever. Well, this is obviously a 45, 45, 90 triangle. All right? This is the hypotenuse. So that means that this side here is smaller. So what we have to do is 6 divided by radical 2. We have to rationalize it. So that gives me 6 radical 2 over 2. 2 and 6 cancel. That's off a little bit. That's 3 radical 2 there, and 3 radical 2 there. So the area is going to be length times width.
You look familiar.
3 radical 2 times 3 radical 2. 3 times 3 is 9. Radical 2 times itself is 2. So that means that the area.
Nothing. Your smile reminded me.
The area. Sorry, the board's off a little bit. Is 18 units squared. 18 square units. Alright? Now, this one, number 2, we just learned this. This is the area.
Oh, the wax. It's dripping. I like it between my.
Is 1/2 8 times 12 times the sine of the angle that they form. And you literally just type that in your calculator. So half of 8 is 4. 4 times 12 is 48 times the sine of 125.
Go out. Your candle's out.
And you end up getting 39, say round. There's 10. So 39.3 units squared. Okay. And number 3 would work the same way. 1/2 5 times 6.4 times 85, sine of 85 degrees. And if you want to do that on your own, I will tell you the answer is you should get is 15.9 square units. Okay, on to the new stuff for this section, 10.4. Inscribed angle. An inscribed angle is an angle whose vertex is on the circle, and the sides are chords of the circle. Okay? So, this is the vertex. Remember, the vertex is formed as the center letter Okay, so when we name that angle, it would be angle ABC or CBA. It's the middle letter. So angle B is the inscribed angle because B is on the circle edge, and AB and AC, I'm sorry, AB and BC are both chords. Now, the arc that connects A and C is called the intercepted arc. Alright? If the endpoints of a chord or arc lie on the sides of an inscribed angle, then the chord or arc is said to subtend the angle. That's a new vocabulary. So if you look at this, arc AC subtends angle B, and line segment AC subtends angle B. Now, new theorem.
Today for you.
Measure of an inscribed angle theorem. The measure of inscribed angle is 1/2 the measure of the intercepted arc. So remember, careful on this one. If we do this, the measure of the central angle is the same as the measure of the arc. But when we pull this out and it's on the edge, not from the center, we have to take that same arc that we would normally do and divide it by 2. So, find the measure of T. Okay? Well, let's look at what we got here. The measure of angle T is right here. Okay? And the arc is 48 degrees, correct? But remember, since T is not in the center and it's on the edge of the circle, we have to divide that by 2. So that's going to be 24 degrees.
In all her glory.
Now, QR, let's look at that. Okay, so this one is a little more complicated. So I'm going to erase right now this and draw over. Now let's think about this. Let's first look at QRT. Now, the angle is 50, which means this right here is twice that, because R is sitting on the edge of the circle. So this is really 100 degrees out here. Now, we have to think about the fact that what is TR? TR is the diameter. It goes through the center, which means this entire arc here is 180. Well, if this piece here is 100, that makes this 80 right there.
Fighting with microphones, freezing down to my bones, and to top it all off, I'm with you.
I know that was a little bit much, so if you need to hit stop and rewind, go ahead and do that. But this is going to be 80 degrees. I hope you understand step by step how we got there. Alright, example 2. Find the measure of RS, the arc RS, which is going to be right here, and the measure of STR, which is actually going to be STR. So you got to pay attention to whether it's asking for an arc or an angle. And what do you notice about STR and RUS? Which is, RUS is right here. So we'll get to that.
In heels.
Okay, so RS is the arc formed by RUS. Now we know the angle measure for RUS is 31. Remember though, since it's not coming from the center, we actually have to double that. So that makes SR 62 degrees. So the measure of arc RS is 62 degrees.
Gotta look on the bright side with all of your might.
Now, we also need to find STR. Well, if you look at that, STR and RUS have the same arc.
Dance a tango to hell.
At least I'll have
Okay? Therefore, STR is also 31.
till your diva is through. You pretend to believe her, 'cause in the end you can't leave her.
And there's no way to write that, but this right there is also 31 degrees. Because both of them hit this same part right there. Like the color. They both have the same arc right there. So even though they come from different parts of the circle, they are both 31 degrees. And the arc is 62. Okay, new theorem. Inscribed angles of a circle theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So let's look at this. ADB. Okay, so this theorem is actually, we just proved it based on the previous problem we just did. So if you look at ADB right there, and we look at ACB, they both intercept the same arc right there. Right? So therefore, if the two inscribed angles of a circle intercept the same arc, we know the angles are congruent. And that's why we have this mark here and here. Alright, so example 3. Given that the measure of angle E is 75, alright, so let's look at that. It's already in blue, I'm going to highlight it. So angle E is right here. What's its intercepted arc? GH. Find the measure of F. Well, angle F also intercepts that same arc, GH. Therefore, the measure of F is also 75 degrees. Alright. Inscribed polygon. In meaning inside. So a polygon is an inscribed polygon when all of the vertices or the corner points lie in the circle. The circle that contains the vertices is called the circumscribed circle. Okay, so if you remember from history, to circumnavigate the globe, you go around the world. So circum means around, and scribe means to write. So to circumscribe means to write around. So to draw the circle around the polygon. Alright, two new theorems. Inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, going the other direction, if one side of an inscribed triangle, or an inscribed polygon, is the diameter of the circle, then the triangle is a right triangle, and the angle opposite diameter is the right triangle. So since ADC is a right triangle, AC is the hypotenuse. No, sorry, since ADC is the diameter, then that is also the hypotenuse, which means our right angle is right there at B. And then a quadrilateral. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So, if you draw a polygon, quadrilateral, inside a circle, and D, E, F, and G are all on that circle, then D and F are 180, and E and G are 180. Okay? Opposite angles are supplementary. Now, here's the thing. We've been used to saying that, consecutive angles are supplementary, but this is a different creature, different animal. When it is inscribed inside, those are parallelograms. This is just any quadrilateral. So in this case, opposite angles are supplementary. So taking what we know and kind of turning it on its head. Okay, so right here, we have a triangle inscribed in a circle. BA is the hypotenuse, which means this down here is the right angle. So we're just saying 2x equals 90, therefore x is 45. Simple enough. Now this one, we do have D, E, F, and G all on the circle. Remember, opposites are supplementary. So y plus 120 equals 180. So y is 60 degrees. And then z plus 80 equals 180. So z is 100 degrees. So we're not saying opposite angles are equal anymore, because that's in a parallelogram. We're talking about just any old quadrilateral drawn inside a circle. And last but not least, example 5. Your camera has a 90-degree field of vision, and you want to photograph the front of a statue. You stand in a location in which the front of the statue is all that appears in the field of vision. You want to change your location. Where else can you stand so that the front of the statue is all that appears in your camera's field of vision? Well, let's take what we just learned about inscribed shapes and especially triangles inside a circle. So if I drew, if we thought about this as the diameter, and we just drew a semicircle right here, okay, then basically anywhere I go, I'm going to have the diameter and there be in my field of vision, and so therefore anywhere I go, I'm going to have a right angle, no matter what, because my diameter is right here. So as long as that is the diameter, anywhere along that semicircle will work.